the last number of months, and still a fair bit to go through. So really appreciate their participation. So Katie, I'll turn it over to you.
Alrighty, thank you. Yep, so I get to be the person that gets to go through all the math, right? And math certainly wasn't my favorite subject in school, but then I became a nutritionist and I realized I use it a lot more than you might think. So hopefully we'll get through this as painless as possible, and I hope that at the end you can understand how important some of this math is. So a lot of these numbers up here are examples, so they're things that when you take these practices home and you start thinking about how you're going to implement things on either your own operation or on the operations of producers that you're working with, just understand that a lot of these numbers are subject to change. So it's the concepts that we're really trying to get across through here. So there's a lot of terminology when we start getting into grazing terms, and I think sometimes it's really easy for us to maybe use things interchangeably that aren't necessarily exactly the same. There's a little nuanced differences there. So I wanted to cover some of that as we go through here. So Animal Unit Month, AUM, that is the forage to support, and this is the number, the standard number that's used, 1,000-pound cow for 30 days. So we say a month is 30 days, we're going to say 1,000-pound cow because it allows us to standardize. Now, I don't know about you all, but I don't see too many 1,000-pound cows, so obviously if we're thinking about 1,400-pound kind of cows, we would use something like a 1.4 there. And so when we think about using this number, how we use this number, basically the dry matter intake, or as we've talked about, is about 90% of that body weight for a month. And so again, this allows us to get a little bit more standardized as we move through. Stocking rate, pounds or number of animals per unit of land over a given period of time, right? So if we're talking about a longer period of time, so maybe the entire grazing season, this is going to be very similar to carrying capacity. If we're talking about a shorter period of time or a snapshot of time, though, then stocking rate starts to look a little different. So if we're looking, the example we gave here is 2 steers that weigh 600 pounds, and they're on there for 100 days. We've got 1,200 pounds to the acre as our stocking rate there. So 2 times 600 to get the 1,200 pounds. Stocking density. This is the relationship of animals to land at a given moment on a given land base. This is really a snapshot in time. And really where this kind of comes into play, a lot of times if we're looking in some of like our popular press articles and things like that, we might see people talking about these extremely high stocking densities. We start talking about mob grazing and some of those practices. We see these really high stocking densities, but understand that that's a snapshot of time, a short period of time, not necessarily over the entire grazing season. So the example that we give here is 40 cows. Okay, now we're up to that 1,400-pound cow that we all go out and see on a half-acre strip. So again, very intensive grazing, and say we're out strip grazing, maybe some stockpile tall fescue. 112,000 pounds per the acre is your stocking density. But again, understand that it's a moment in time, a snapshot in time, not over the entire grazing period. So, why is this important? Well, this question right here, right? This is a common question that we need to think about, right? How many cattle can I graze on my pasture land? That's a very practical question, right? Because if we're overstocked or understocked, either way, we're giving up some productivity there. And so it's an important concept to understand. The other thing that's really important to understand is that this number is very individualized. What kind of, we said cattle here, are we talking cattle, or we've got a lot of small ruminant folks in the room, right? Obviously, those are two different critters. Those are going to be two very different numbers. So again, going through and kind of thinking about this really helps us understand how we can utilize the land that we have available to us. So stocking rate is that combination of both economical and environmentally sustainable rate that we can use across the full grazing season. And so this is the number that can be really useful for us to really understand, so we don't get into a situation where we're really understocked or we're really, really overstocked, right? Because we see that, I see that from time to time when I go on operations, and that's a tough conversation to have with somebody when I have to say, you know, you've probably got a few too many head out here for what forages you have available. And so that means we've either got to change the number of cattle, or maybe we've got to change the forage program to match that. But we've got to kind of walk through this and really understand the numbers that we're using so we can get to that final answer. So carrying capacity, the way we calculate that number is annual forage production times the seasonal utilization rate, right? And so so Dr. Smith talked earlier, he had showed that really nice table and talked about the different utilization rates. So think about that. That number's going to change from operation to operation. Is this an operation where we've opened all the gates, we're just going to turn them out and let them fend for themselves for the next 5 or 6 months? Or are we going to be rotationally grazing them and moving them twice a day, right? Or most people are going to be somewhere in the middle. Their average intake, so then we do that over their average intake times the length of the grazing season. Don't get too hung up in all this. We've got a worksheet to go through, and I think that really helps kind of put the math into perspective. So we'll actually walk through this together with some examples that you can use to calculate this. So again, let's walk through this, because this is a great example. This is a typical example, I would say, of maybe a Kentucky cow-calf beef operation. It doesn't get much more typical probably than the numbers that we've got up here, okay? So we've got the weight of that cow. Okay, so if you remember back to the very first number we talked about, animal unit months. So we've got that 1,300-pound cow. She's 1.3 animal units, because we base that on 1,000 pounds. So we're going to assume that 90% of that is her dry matter intake for the pair, right? Cow-calf pair. So 900 pounds of dry matter times 1.3. So we get that number again, 90% of 1,000. That's where the 900 comes in. We're going to multiply it by that 1.3. So 1,170 pounds of dry matter intake of forage is what we need for that pair. Now, let's factor that out for the whole operation. We've got 35 cow-calf pairs, plus we've got a bull out there, so let's not forget the bull. The bull's going to be around. He's going to be eating, so we got to think about that. So 1,800-pound bull, 1.8 would be his animal unit. 1,170 pounds of dry matter intake, so multiply that there. So then if we multiply that 1,170 by our 35 pairs, we get 40,950 plus the 2,106 from the bull. So altogether, we need 43,056 pounds of dry matter intake per month. Okay, that's what the cattle need. Now, what is the land doing for us? Okay, so we think about 8,000 pounds of dry matter per acre. We've heard this concept already this morning, right? Take half, leave half. Okay, so we're going to take half, we're going to leave half. So we don't actually have 8,000 pounds of dry matter per acre for the cattle to consume. We've got 4,000. Now, again, some of the operations that we can go on sometimes don't follow that same policy, but we're going to live in a perfect world today, and we're going to take exactly half and leave the other half there. So let's say we're on an 80-acre farm. they're going to consume 4,000 pounds of dry matter per acre. That's 320,000 pounds of dry matter. We're going to divide that by how many pounds of dry matter we need our cattle to eat in a month. And so that's 7.4 months. Multiply that by our standard 30 days in a month. That equals 225 days at 2.3 acres per pair. Okay, so that's what we're able to do off of this particular operation and scenario. So this is up here for you all to have, so you all can kind of think about how these numbers are calculated. But these are just examples, right? And these things get adjusted over time, right? Our number of head might change, our land production might change from year to year. So just understand that these aren't hard and fast numbers, but the concepts are, we just have to adjust our numbers as needed. So, we talked already this morning about the benefits of rotational grazing, and I think you're going to continue to hear that throughout this program. But one of the first things that we need to think about if we're going to try to rotationally graze is how much area do we need for the cows, right? That would be one of the first things we need to think about in each of those individual paddocks. Before we can even really start thinking about where those paddocks might go and do we have water for them, we need to start thinking about how big do they need to be so we can fit that into context on our operation. And so this is where we're going to go through the worksheet there. And so we're going to break you all up into groups. And these will be your groups that when we go out to the farm for the hands-on piece of this, you'll be in those same groups.
Okay, since we've got a very diverse group, rather than just divide up by tables, we're actually going to, remember elementary school, you count it all, playground. So we're going to do that. So it means you've got to count out loud, and you've got to remember the number that you say. If you're here as a couple or business partners, if you want to both be in the same group, that's fine. But we're glad if you're separated too, as far as just diversity, and maybe you might learn some more things. So we're just going to start here. Again, write your number down because that'll be really important to get in the field. So 1, 2, 3, 4, 5. 5. 5, 5, 8, 6, 7, 8. I'm sorry. We're going to have 8
groups.
We're going to have 8 groups. Sorry, just put you in the spot there. 1, 2, 3, 4, 5. Everybody got it? Okay, so when we get to the field and we're dividing up, we're saying all this group goes to this paddock. Just remember that number. But also, Katie's going to take you through an exercise, and each group is going to be doing a little bit different math. Now, if you get lost and can't do it, you know you've got a bunch of group members that can back you up. All these students here, they're going to have it perfect. So don't worry. I mean, we want you all to try it, but don't worry if you kind of get confused. But I think Katie's going to take you through here really clearly. Yep. Anything else to tell them, Katie?
Nope. Okay. I'll go over the changes on this when we get to it. So, all right. So information that we're gonna use today, and we'll give you the numbers. I'll walk you through that. But again, when you go to apply this on your own operation or working with a producer, number of head, right? And we put livestock on there, right? Because this is going to be multi-species sometimes. How much do they weigh? And an estimate of their intake on a dry matter basis is a percentage of their body weight. And so we'll talk about that for cattle, and in your slide set there is an example for small ruminants as well, because they are a little different. Available forage dry matter, again, that take half, leave half. That's not the total amount that's out there, but how much is actually out there that we want the cattle to graze. How much time are they going to be in each paddock, right? So are we talking twice a day moves? They're in there for half the day. Are we talking once a week kind of moves, right? Because we work off farm, have a full-time job off the farm, and it's really not practical for us to get out there and move cattle in the dark. Cattle don't like to move in the dark, so we're going to move them once a week on the weekend when we've got the time and maybe the kids are home from school and we have the ability to do that. Percent utilization of the forage, paddock numbers, right? How many are we going to have so that we can allow for rest? Fixed width, that number on there, we've got 45 feet. That's just an example. What we are actually using today is actually going to be a little narrower than that. We'll walk through that on your worksheet. And so then what we need to solve is the total area. And then if we know how wide that paddock's going to be, then we can determine the length of the paddock. Okay, so go ahead and turn to the page that looks like this in your handouts. All right, so right off the bat, we're going to make some changes to what's in that table up there, okay? Okay, so, and it may be easier because there are some examples to follow along in your slide set, so it may be easier just to open the binder and pull that out. All right, right off the bat, number of animals, it's listed as 2. We had some extra, so everybody's going to have 3 animals per paddock. So go ahead and change that to 3. Paddock width is going to be 35 feet, not 40. Where it says heifers weigh 800 pounds, we have more of them and they're a little lighter. So their actual weight, our herd manager out at the farm weighed them. They averaged 735 pounds. So we're going to use that number instead of 800. And then we've actually already gone out and evaluated the available forage. And again, we accounted for leaving that residual. So the available forage in terms of pounds of dry matter per acre that you need is 1,900. So that should be all the numbers that we need. So number 1, first thing that we're going to calculate is the amount of forage needed by the cattle on a dry matter basis. So each of you may have a different utilization percentage that we gave you, right? So that's where you're going to see that there's a difference there as you move through some of these calculations. But in terms of that intake of dry matter as a percentage of body weight, we put 3 on there. For cattle, we typically think in the range of 2 to 4, so 3 falls pretty nicely in the middle there. One thing that I will note on that is sometimes that might be an overestimate, but I would rather overestimate than underestimate in this scenario. So you can go ahead and calculate number 1 using the numbers that we gave you, right? So put in the animal weight. We're going to multiply that by the number of head. 735. Then we're going to multiply that by the dry matter intake as a percentage of body weight, but we've got to make that a decimal, so that 3 divided by 100, or 0.03. And then the other thing I didn't necessarily tell you is how long they're going to be in each paddock. So in this example, because we're going to turn them in later today, they're going to be in there for 0.75 days, 3/4 of a day. So that's the length that we're going to use for our example here. So we'll walk through, and once you've got that number for number 1, go ahead and put it on the line there. Yes. Yep. I did it. I can check your math and put you on the spot. All right, what number did we come up with? We should all have the same number at this point, regardless of your group number. So you can copy off your neighbor if you want. Yeah, that's what I got. So 735 times 3. Sorry, yes, 735 is the average animal weight. 3 head times 0.03 times 0.75. Yep. All right, so did we get to 49.6? $49.6. The percentage decimal point thing throws people off. Yes. Point. Yep. So you guys get it? All right.
Well, I was doing it old school, and then I got worried about
the decimal. Yes. The 0.75 also probably, because it's not a practical number, right? So if that, like, if you were doing once weekly moves, it'd be 7, right? That's an easier number to comprehend. All right. So I think there's a good teachable lesson in here. One of the biggest takeaways I learned in graduate school as I was trained to become a ruminant nutritionist was that decimal points kill. And that's a very accurate statement. I worked with a lot of micronutrients, right? So sulfur, for example, is a prime example. If we're off by a decimal point, we're going to kill cattle. And so luckily, this case, we're not going to kill cattle by being off by a decimal point. But decimal points matter, and they can really trip us up. So our next step, we've got to do the same thing with with the decimal point. So instead of multiplying by 3, we had to multiply by 0.03 because we divided that by 100. So again, that's probably the part of this, the trickiest part of the whole math problem. But, so right now we should have 49.6, we should all have the same answer. So this next part, this is the part where we're going to get a little different from our neighbor potentially. So, we need to calculate the amount of standing forage that is available to be consumed after accounting for utilization. So, if you look at your table based on your group number, we gave you all some different utilizations. So you're either a 40, a 60, or an 80. I gave you the pounds of standing forage after accounting for leaving 3 to 4 inches there. So that first number that you need to calculate number 2 would be the 1,900 pounds. Now we're going to multiply by our utilization rate divided by 100 again, so similar to what we had to do with the 3% in the last equation. We need to do that with our utilization. So for example, if you have 40, that's a 0.40. And then that's going to give you the adjusted forage dry matter that's available per the acre.
I just say that we estimated the forage yesterday by clipping quadrats. We'll do that when we go to the farm today. And when we clipped those quadrats, we clipped the forage above forage. So that means we left forages residual in the pasture. Now, if you clipped it all the way to the ground, you have to subtract out that base of that plant. But as Donna said, it's not quite equally distributed. It has to be a little bit thicker base. So clipping it above that 4 inches gives you the actual dry matter that the animal has available.
Someone else missing this calculation? Anybody not
Necessarily have to do that.
Yep.
Utilization rate off this one or off this one?
Do it off so in your notes, in your PowerPoint notes, there might be little different numbers used. We're doing all of our calculations off of this sheet.
When you think about it, you're going to be getting 80% of what's there, so 80% of 1,900 would be about 800, and then 80% of 720 or something. So it should be around 15.
Yeah.
It's not easy getting utilization. You really have to crowd those animals to make them index.
Yeah.
So you'll see that. So you're probably going to be around 16 or 17.
Yeah.
16.
All right, so several of you would have 40% utilization. So if you're in groups 1, 4, or 7, what number did we come up with? All right. What about for groups 2, 5, and 8? 60% utilization. 1140, right, for the 60% utilization group. What about for our 80% groups, 3 and 6? Yep. 1520, okay? So, now we're going to calculate the number of acres that we need, okay? So, if you've got your, if you're on your worksheet, you've got arrows pointing to where we're going to pull numbers from, right? So this is why we really need to make sure we get number 1 and number 2 correct, because we're going to use those numbers now, right? So we need the pounds of forage of dry matter that our cattle need. So that's what we calculated in number 1. So go ahead and write that number in A on that first blank for 3A. Then we're going to divide that by what we came up with in question 2. So for our 40% group, that was 760. It was 1520 for the 80% group, and 1140 for the 60% group there. Okay, so once we've got those numbers plugged in, you see we're going to ask you to divide that, right? So we're asking you to take the total pounds of forage needed, divide by the pounds that are actually available, and we'll get the acres per group per grazing period that we need. So, get a pen. Let me grab a pen so I can kind of like do the math for the other 2 groups, because I just have my example one on here. Should have done all the math. Huh? Thanks. That's right.
It's going to be a small acreage, right? What did you guys get for your acreage? 329?
Yes.
Yeah, okay. You were at the 80%, right?
Yes. All right, so remember we only have 3 head, and they're only going to be in there for 3/4 of a day, so our acreage number doesn't have to be very big. It's not going to seem, you're going to probably look at it and think that's not very much land, but remember, for this exercise, we're talking about small numbers.
Did you, how'd you get that? 0.65 times 43, 560.
For the acreage or the square foot? That's square foot. That's your square foot number. You're one step ahead. You're good. Yes. Okay. Yeah. Yeah, because yeah. Yep. You're close. We've got some decimal rounding that is probably going to throw us off a little bit, but yeah.
For the actual acreage part.
Yeah. Yep. You were 60% utilization group. Yep. Yep.
Because that's how long you'll be in there.
Yeah, it's got it.
Yeah.
All right.
Utilization.
So that's just based off of, we just wanted to give you guys some numbers, yeah, that are going to vary, so you see the difference in size of the paddock based on what our target utilization is. But if you think about it, it really would depend on how frequently you're moving and that kind of thing. Yep. We get our answer? All right. Yep, that looks about right. All right. Okay, so for part A, for the 40% utilization groups, what number did we come up with? The 40% utilization groups, so 1, 4, 7. What did we come up with in terms of the acreage that we need? I heard it over here somewhere, 0.0652, depending on how we rounded. What about the 60% group? So groups 2, 5, 8. Yep. 80% groups. How much acreage do we need for them? Yep, so 0.03. So now we're going to convert that to square feet, right? Because we're actually going to measure these out and make sure we get the right size paddock. So we need to be able to do that in something we can measure easily, so feet. So if we take that decimal value there that we got for the acreage, we're going to multiply that by 43,560 because that's how many square feet are in an acre. So that'll give us our total square feet that we need for each group for the grazing period. So that's, some of you may already have jumped ahead and got that number. Let me calculate the other ones out here. So do we have our square footage calculated? What was that? 2831, so 40% group, I'm guessing. So I got 2844, but that's probably a decimal on the, you may come up with slightly different answers depending on how you rounded your acreage needed. You're going to come up with a slightly different answer. But 2,800 and some change is going to be in the ballpark for our square footage for that group. What about the 60% group? 1894, 1895, right? Somewhere in that range. What about for the 80% group? 1420, 1421? Yep. Okay, so we already told you that our paddocks are going to be 35 feet wide, right? That's just the set width. So because they've already set the width up for you, and we just need to now we're trying to figure out the length. So if you take your total square footage, right, which is length times width, if we divide by the width, because we know what that is, we know what we want that to be. We're trying to solve for length. So take our total square footage, divide by the width, and that'll get you the length. All right, did we get some lengths calculated? Where are we at for our 40% group? 81? Yep, that's what I got. What about our 60% group? 54? Yep, that's what I got. 80%? There you go. I rounded mine to 40, so that's what I got there. So now we can go back and we can basically go back and check our math, right? And so I wanted to show you how to do that. Now that we've come up with our length and our width, we can go back and make sure that square footage, after we've rounded, fits into our total acreage. So if you take your length and your width, you're going to go back to square foot and recognize that now that we've rounded off those lengths, that number is probably going to be a little different than what you calculated in 3B. Hopefully it's a little smaller so we know it fits. Then you can take that, divide it back by the 43,560 number that we gave you to get acres in your paddock. And again, you want to go back and make sure that number matches what you came up with in 3A. So that way you can go back and double check these things as you go to make sure we did it right. So we want to make sure that the dimensions of the paddock that we came up with actually fit within the acreage that we determined we needed. And so then we'll pick back up with that actually once we get out in the field. I think he's got a couple more slides in this slide set though. So one of the things that we didn't talk a whole lot about, but as we think about utilization, we need to think about trampling losses. And so again, these are just some pictures that Dr. Lehmkuhler, I believe, has taken that show actual trampling losses. They are real. They do happen. These critters do take care of some of that for us. Number of paddocks that we need. We didn't cover this in that handout because we're not. If this was a week-long course, we might be able to do that. But important to think about this math concept as well, right? How many, now we've figured out how big they need to be, how many of them do we need? And that's really dictated by the rest period that we're looking for. So days of forage rest divided by how long they're in the paddock, and then you're going to add 1 so that we've got our extra one on there. So if we wanted a 28-day rest period, we're going to move them once a week. We need 5 paddocks. And so again, that's useful for information for you all to take home as you're thinking about setting up a rotational grazing system. This is the kind of things that we need to think through before we ever go out and start laying our temporary fencing and those kinds of things. So we talked a lot about math today, right, and ideal situations, but understand that nothing in agriculture is an ideal situation. It's not always by the book. So forage production is not going to be static throughout this season. You saw that in both presentations earlier. We talked about how that fluctuates throughout the year. So our grazing management can't be static throughout the season. Throw in something like an early season drought or something like that, that's going to affect those things even more. So it's going to vary even within each rotation. Each time you're going through there, that standing forage availability is going to differ. So a lot of times we need to think about, while ideally we want that 7-day period, obviously if the cattle are out of grass before that, we need to speed it up. Most of the time we're going to be dealing with a fixed number of cattle within the system. So at least we can have that as steady, and we can adjust our moves or our sizes based on that static number. Calves eat forage too, though, so don't forget about that if we're working with a cow-calf system. We have to think about the calves as well. And so if you go back to that example that we showed with the 35 cow-calf pairs, we've got some of that in there. So with that, I know that was a lot of math, right? So, but we've got our numbers now. We all got to the right place, and so I'm happy to answer any questions or.
So we're going to throw one more twist into this whole math calculation. That's that some of Kirk's paddocks out there have considerable wheat load. So you guys are going to have to decide